Right. Now let's look at the following circuit. And in this circuit, I built it to verify Ohm's law. So I will investigate the relationship between voltage and current. So we have a voltmeter here, and then this is the ammeter. Voltmeter is to measure voltage, and the ammeter is to measure current. And I have a bulb, which is acts as a resistor, and it has a resistance of 20 ohms. Okay. So as you can see that this circuit is open, so there's no current flow that's gonna flow. So connecting the ammeter in series, but the ammeter still reads 0 because the circuit is open, but the voltmeter reads 5 volts. So what I'll do now, and then this is a table. I made a table to record my results, as you would do when you're doing an experiment. Okay, so then I close the switch, and then there's current flow, and the voltmeter reads 5 volts. The ammeter reads 0.25 amperes. So then I will record these results, my initial reading on my table. That's voltage is 5 volts and current is 0.25 and resistance is 20 ohms. What do I do is that my independent variable is voltage, so then I add a battery. So that means that adding a battery is changing the voltage. So this is what I mean by manipulating the variable. So this variable is being manipulated, is the voltage. Now we change it to 10 volts. Then the effect of changing the voltage or adding a battery, then we measure what does that do to the current. Then that means then our current is a dependent variable. So we make a change on the voltage, and then we measure the current. So again, voltage is my independent variable, and the one that I'm measuring is current. That's my dependent variable. I have not made change on the resistance, so then my resistance is controlled variable. Okay. So I add another voltmeter. Sorry, I add another battery. So I'll change my voltage to 15 volts, and then I'm going to measure my current, my dependent variable, which is current. Okay. I think here, let me add the 20 because I have not changed the resistance. I don't change the resistance throughout the experiment. So then what is my current? When my voltage is 15 volts, my current is 0.75 amperes, and then I record my results there. Okay, then I continue the process until I make for reading 4 and 5, and this is my table. So now I completed this first trial. So I have 5 readings. Voltage, sorry, the voltage should be 20 there, 25, yes. So change my voltage 5, 10, 15 up to 25, and then we can see that the current is also increasing. So if I increase my voltage, the current is increasing. Okay. So then what's the next step? The next step is to graph the results. So the graphs, I will graph the current versus voltage. I'll first make scatter plot. and then draw the line of best fit. Okay, so then I'm just going to summarize the first part. So this is my independent variable is voltage, and my dependent variable is current. Controlled variable is resistance. So now what I will plot is current versus voltage, and here's my scatter plot for that. Where is it? It's here. So this is my scatter plot. So these are the points when the voltage is 5 volts, and then I have 0.25 here, and then when it's 10 it's 0.5, and when it's 15 0.75, when it's 20 it's 1 volt, and it's 25 volts it's 1.25. And then what do I do afterwards? I draw a line of best fit. So here is my regression line. So line of best fit or regression line is the line that you draw that best fits your data. So this data is best fitted by a straight line. Furthermore, I'll proceed and calculate the gradient of this line. So the gradient is equal to the gradient, always the change in the variable on the y-axis, so that's I, divided by the change of the variable in the x-axis, so in this case that is v. So, and this is equal to, and then I'm going to select the points. If I select the value when the voltage is 20, then the current is 1, minus the value when the voltage is 10, the value is 0.5, divided by 20 minus 10. So that's the change in current over change in voltage. That gives me 0.5 divided by 10, and that is equal to 1 over 20. We note that from Ohm's law, if you look at I over V, then it looks similar to this equation. R is equal to V over I. So then from here we deduce, and 1 over R is equal to I over V. So this 1 over 20, so this implies that this 1 over 20 is 1 over R. So 1 over R is equal to 1 over 20. So that implies then that R is equal to 20 ohms, and that's why we in physics experiments we use straight line graphs, because we can calculate the gradient and then determine the physical quantity that's associated with the gradient of this graph. So then this is 20 ohms. That is exactly the value we got for the resistance. Here is our resistance, it is 20 ohms, right? Okay, so then in the next video I will continue to look at the other sections of your lab report, which is discussion and conclusion. Okay, so let me stop here for now and then continue in the next video.